Assalamualaikum and hi everyone. My name is Nur Shakila binti Azizan and my number matric is 10DE20F2005. Today I want to do practical work 1. For this practical work, I will be able to analyze and understand IV characteristic curve for silicon diode, and I will be able to know forward bias and revert bias. For this practical work, we have two parts. The first part is measure the diode using the multimeter, and the second part is do the circuit connection. This is two circuit, circuit 1 and circuit 2. The circuit I will do in the live wire to get the result for table 2 and table 3. The thing that we need in the experiment is multimeter, breadboard and diode IM4001. The first thing that we need to do is calibrate the multimeter to make sure the measurement value was accurate. First, adjust the multimeter and touch the probe. Make sure the needle is at 0. Now, we can see at the diode have the grey line. The grey line is negative and the other side is positive. And we have two probes. Red is positive and black probe is negative. Now, I want to do to figure 1A. For figure 1A, it is positive probe touch to negative diode and negative probe touch to positive diode. Now, we can see the result is 6 ohm. 6 ohm multiplied with 10 is 60 ohm. And this is forward bias. Now, I want to do for figure 1B. For figure 1B, negative probe touch to negative diode and positive probe touch to positive diode. Now, let me see the result. The result is 0 ohm. This is because this is reverse bias. Reverse bias not has current flow. Now I want to do the circuit diagram for circuit 1 and circuit 2. For circuit 1, the result at table 2, and the circuit 2, the result we fit in table 3. So the first thing that we need to do is add the component that we use. So this is the component, and we can see the extra one is V for measure VF equal to VO for table 2 and VO for table 3. So make the connection. Connect all component. After that, adjust the diode, choose IM4001, and change the value, same with the table 0. So that we measure. So the value for 0 is 0 ampere and 0 volt. Then we change to 0.1 and we get 2.53 microampere and 97.47 millivolt. Next, change to 0.2 and we get 12.79 microampere and 187.20 millivolt. After that, we change the VI to 0.3 and we get 41.53 microampere and 258.47 millivolt. After that, we change to 0.4 and we get the value 92.27 microampere and 307.73 millivolt. And we change to 0.5 and we get the value 188.64 microampere and 341.35 millivolt. After that, change the voltage to 0.6 volt and we get 234.38 microampere and the voltage is 365.62 millivolt. After that, change the voltage to 0.7 and we get 315.82 microampere and 384.18 millivolt. And last, we change the voltage to 0.8 and we get 400.95 microampere and the voltage is 399.05 millivolt. Now I want to adjust the diode to the another side. This is same with circuit 2. So adjust the VI. The first is 0. And the value is 0 ampere and 0 volt. We change the voltage to 1 volt. And we get 999.33 millivolt and 670 NA. After that, we change to 2 volt and we get 670 NA and 2.00 volt. And we change to 3 volt and simulate, and we get 670 NA and 3.00 volt. And we change to 4 and we get 670 NA 4.00 volt. We change to 5 and the result is 670 NA and 5.00 volt. We change to 6 and the value also same, 670 NA, and the voltage is not same, is 6.00 volt. And the last is 7. For 7, we get 670 NA and the voltage is 7.00 volt. Now we can see at the ammeter we get the same result for the circuit 2. And for the circuit 1 and for the table 2, that we have do we get the microampere, but in this table 1 the milliampere, so we need to convert the unit to milliampere. And for table 3 we get Na, but in the table 3 1 microampere, so we need to change the unit.
That's all from me. Thank you for watching.